What is space? There's space in this box. There's space in this bag.
No space in the fridge.
Thankfully, that's not the space we're talking about. Really, we're talking about our universe, and the universe is everything. It is all that we can see and pretty much everything we cannot see. So when astronomers speak of the universe, they usually mean the observable universe, what technology has enabled us to see, or what the physical laws will permit us to see as technology advances. So let's look at how big the universe is. The Hubble Space Telescope sees 10 billion light years, and a light year is the distance that light travels in 1 year, about 6 trillion miles. So again, as you add notes to this, don't write down every single word. You can kind of paraphrase some of these things. But this gives you sort of a frame of reference. If a light year is 6 trillion miles and we could see 10 billion 6 trillions, that is a long, long, long ways away. And that was launched in 1990. So here's some pictures from the Hubble telescope. Radio waves can sense a few billion light years away. So that's just another way that we can sort of measure different signals that we get from the universe. So what is a galaxy? A galaxy is an assembly of stars and related matter and gas, all held together by mutual gravity. Here we have a picture of the Milky Way galaxy. It's sort of an illustration. It's not actually a photo of this. But this disk shape is sort of an illustration of the Milky Way. Our sun is about halfway out from the galactic bulge in the center. That's where our sun is. So we actually get a great view of our galaxy, of the Milky Way, and of the universe, as far as we can see, because we're not clouded by all of these stars and particulates. We revolve around this galaxy. This galaxy spins about every 250 million years. A star is a great ball of fire. That is our sun, right? A planet is an orbiting body large enough to become round due to its own gravity. So that is the definition of that. And as with the galaxy, the definition of planet has changed quite a bit. Initially, we had Pluto as one of our last planets, and then people started getting upset about that and calling it a dwarf planet and all of that. So we're also looking at, this is another definition, it's large enough to dominate the vicinity of its orbit. So it has to dominate, and that's when people said, well, Pluto's maybe not really a planet. So it's now considered a dwarf planet. It would actually hardly cover the size of India if it was sitting on Earth. So it's that gives you kind of an idea about how large it is. So it does not dominate the vicinity of its orbit, and people are really sad about that if they're old and liked Pluto as a planet. So here's our order of planets. We have terrestrial or Earth-like planets: Mercury, Venus, Earth, and Mars. The gas giants are Jupiter, Saturn, Uranus, and Neptune. And then the dwarf planet of Pluto. The mnemonic for that is, my very educated mother just served us 9 pizzas. What's a moon? A moon is a natural satellite. There's about 90 in our solar system. Mars has 2, Mercury and Venus have none. And our moon is actually unusually large considering the size of Earth. It's about 1/4 the size of Earth. And it's in our gravitational pull, but it is large enough to pull back. And the result of that is tides. So it's so big that it pulls water from the Earth towards it. And that is actually what creates our tides. As the moon is orbiting around the Earth, then those tides vary. One neat little mini fact about the moon was that it was one of the first that was our hands-on experience with a finite speed of light. The average distance to the moon is about 240,000 miles, and light travels 186 miles per second. So that's over 1 second for a light signal to reach the Earth. And that was noticed when they tried to transmit images from the moon onto Earth in that some of those early Apollo missions. So as we said, it's a natural satellite of the planet. Now let's look at how old the universe is. Well, you could say it started with the Big Bang, that as far as we know, it is 14 billion years ago, given the evidence that we have to measure. We observe shifts of light as redshift, and it allows the measurement for speed at which galaxies are moving away from us. And so then they kind of run that, the speed at which they're moving away, they sort of run and play those things backwards and come up with an approximation of 14 billion years, when they thought everything kind of came from one central moment called the Big Bang. And what that caused that is there really is not a scientific explanation for what caused all of these things to suddenly just become. So they're calling it the Big Bang. Distance in space. So now it's your turn to observe the size of space. You're going to go to a link, and it's really kind of cool. It gives you sort of a frame of reference for how large space actually is and how small we are with respect to not just our galaxy, but the entire universe, or at least the known observable universe.